So thanks very much, Jonker. First demonstration of the day. We're right at the other end for all you who are having a look at the big yellow diggers up there. So make your way down this end. My name's Graham. I work for a company called Fireward. Fireward are one of the UK's leading distributors of fire suppression systems for the type of machinery that we see behind. Now, many of you, if you've been to these shows before, would have seen us before. We normally do a demonstration where we compare powder and foam in terms of fire suppression agents and putting fires out. Now, over the years, we've all learned that powder is by far the best, backed up by foam in dual agent systems. That's a fact. It's far quicker, far more effective. What we're showing you this year, though, is something slightly different. And we're not just talking about how quickly and how effectively we can put your fire out, because powder does that by far the best. This year what we're going to be demonstrating is actually the detection of that fire. How quickly can we detect that fire in your machine? Now, every second that goes on with a fire ablaze inside your machine is costing you money, not just in the downtime but in the repair time. So more fire, more time, more damage is going on. So the whole idea is actually to detect a fire fast. Hopefully these things don't fall over, but detect a fire fast, also put a fire out quickly and effectively. So what we have behind me is our demonstration unit. Now, the demonstration unit is set in two halves. On the left-hand side, we have our pneumatic detection. We did have a sign against it, but unfortunately that's just fallen over. On the right-hand side, we have our electronic detection. Now, the two types of detection, pneumatic against electronic, what are they? Pneumatic is very simple. It's very quick and very easy and reliable. Pneumatic detection is basically a plastic tube. It's designed and dedicated for the fire suppression industry. It bursts at around about 180 degrees. It releases the gas and opens up the valves on the cylinders. It's very, very simple, very quick and very effective. With an electronic detection, which we can also supply, we just have a preferred version. With electronic detection, it has to, one, detect a fire at the same temperature, around about 108 degrees. Then it has to go through a sequence. Wires have to touch together. It has to signal a box to signal another component to then release the pressure within the system and actually activate the cylinder itself. So what you end up doing is actually getting a delay. Delay, remember what I said at the start? Equals time, that equals money, that's more damage on the machine. So what we're going to do is actually set some fires alight and use the automatic systems that they both are together at the same time and compare the difference in the detection and discharge times. One will detect extremely fast and put the fire out. One will detect not as fast but also still put the fire out. So on the left-hand side, as I say, we have our detection system. It runs around at exactly the same height on both sides. We have one nozzle sitting at the top in each bay, and we also have 1 kilo of powder on each base. They're both identical tests using the same trays, using the same fueling, and ultimately the same fire. So what we're going to do is shut the doors, or light the fires first, shut the doors, but we're going to time how quickly and effectively each one goes. So with my glamorous assistant to my right, Dion, he is holding both stopwatches. We will time each one and then we'll compare the difference at the end. And you'll see, and it's quite obvious to see, which one is our preferred version. If some, Dion, can you grab this door for me, please, mate? Ready? So, both fires are lit. They're both going together. And ultimately, the left-hand side, the pneumatic detection has actually already discharged. It's already fired off at 5 seconds. On the right-hand side, the electronic detection is taking a bit longer. So what it's going to start doing in a moment, you'll hear one beep. That one beep is a signal, the detection going, there might be a fire. The second beep is, oh, there is a fire. And then it goes into a 10-second cycle delay. That cycle delay allows the electronics to back down, the driver to operate or to get out the cab, move the machine, that side of things. However, we're talking about a fire still going on in your machine, on your pile, in your business. And we might take a little bit of a delay on this one. So she still hasn't detected just yet. There we go, that's the first beep. So that's the detection of a fire. We're still going through, so the cycle is still going. Now we're into a 10-second delay. In 10 seconds time, the system will go off and put the fire out. But again, remember, your electrical harnesses are still going, your hydraulic components are still going, and now the system is discharged. So that's both systems that Fireward use. There's two different types of detections on the market. You have pneumatic, fast, quick and effective, which is the preferred method of Fireward, or you have electronic detection, which is still a detection system we can use and some customers ask for. However, it's noting the difference between the two. So ideally what you want, 1 minute and 1 second compared to 5 seconds. We've got a marked difference between the two detection systems on a machine. So the whole idea when looking at your fire suppression system isn't just looking at dual agents, which by far is the best system. We also need to be looking at your detection system. Detect it early, put it out fast, and that's what Fireward does. So come and see us afterwards, but thank you very much for your time. I'll pass back to Onka in the next demonstration.
Fantastic, Graham. Thank you very much. Let's give a round of applause for Graham for this fantastic machinery as well. This can absolutely make a massive difference as well in OBE.